Well, good afternoon, good morning, or good evening, depending upon where you are, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to listen to it on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question. And we'll take as many questions as we can near the end of today's webinar. Okay, with that, we'll go ahead and kick off today's webinar, which is Migrating to Microservices. It's easier than you think. Our speaker today is Steve Taylor, who is CTO of DeployHub. Hi, Steve. How are you?
Good. How are you?
I'm doing great, thanks. You're going to put yourself on camera now?
Yep. Should be coming
across.
All right,
there you are. All right, great. Well, I am going to put myself on mute and let you get right into your presentation.
Great. Thank you. So I'm Steve Taylor, co-founder of DeployHub and OpenMakeMeister. I specialize in doing builds, releases, work around Kubernetes and service mesh. I've been doing this type of line of work for a long time, over 25 years. So dive right into this. Today's agenda, we're going to go ahead and take a walk of a roadmap of migrating our application from a typical J2EE application, let's say like a JBoss web app, and moving that over to microservices. What's that mean? What's that roadmap look like? As part of that roadmap, we're going to take a look and see what changes we need to make to our CI/CD pipeline. And then also as part of this discussion, we're going to talk about how domain-driven design plays a role in our migration from a monolithic to a microservice. So our standard roadmap that we're going to use, and this can be applied to not only to a J2EE application, but it could be applied to basically any type of monolithic application that we want to go through. So some of the first things we're going to do is we're going to start with our native JBoss, Tomcat, Java app. One of the things that we're going to do first is we're actually going to take that application and put it into a Docker container. From there, we want to bring in Nginx. We'll get into details where we're going to bring in Nginx. And then we'll containerize Nginx, which is a very simple step to do. And then once we have our two containers, our Java application in the container, Nginx running in the container, we'll move that over to a Kubernetes cluster. From there, we want to start taking a look at our domain-driven design, which is how we're going to break apart our application into smaller pieces. And that's going to really drive how we look at how we're going to structure our binary repository and our Docker registry, our repo there. And then finally, we're going to tie all this together so we have a continuous deployment process with auto deploys happening. And at the end of this process, what do we have? We have our application running in Kubernetes, natively in Kubernetes, that provides us a high availability and auto scaling for our application. So to get started, we got to first take a look at some baby steps. One of the things that when we go into the Kubernetes world, we have to containerize our application. So the container, a Docker container, really gives us a box to put our application into. In the past, when we would create our application, we would create an installer, or we'd tell the admins, copy this EAR file over to this application server, expand it out, and then it's going to run underneath Tomcat or JBoss, any of those app servers. But with a container, what we want to do is we want to take our application, put it in a container with all the dependencies. So in the case of our Java application, If we're using Tomcat, we're going to need some basic dependencies in our container. We're going to need the Java runtime or the JRE or the JDK as part of our container. We're also going to need JBoss or Tomcat as the application server. And then finally, we're going to need our application itself, our jars, ears, and wars to be placed into the container in the right location for the app server to run. Now, one of the things that we want to do is we want to make sure that we don't mix and match. We don't want to have a database and an application server together. We want to have two separate containers from that. And once we have it containerized, this is going to allow us to go ahead and move from a standalone Docker environment all the way out to our Kubernetes cluster. So when we take our application and containerize it, we want to make sure that we only have one entry point. In the case of the way a Docker container runs is it actually, you want the process to run forever. You don't want to put it in the background. So in the case when we start like a Tomcat server up, we're going to start the Tomcat server up in the foreground, and that's going to be our entry point into our container. And that's going to run in the foreground forever. Once it exits, the container exits, and we don't want that to happen. We want to basically use the container as our daemon, and we just start our process in the foreground. Like I said, we don't want to mix and match. We don't want to try to do a database engine like Postgres or MySQL in the same container as our Java application. Because what ends up happening is we end up having two entry points. And containers, you can do it, but it gets really funky on how the communication happens and the processes, the way they are going to network together. What you really want to do is have a container for your MySQL, your Postgres, and then a separate container for your Java application. And everything that's needed for your application should be in there. So when you go through and do your Docker build, you're actually going to pull down all the packages at the OS level that are going to be needed for your application to run. So if your Tomcat instance or JBoss instance uses SSL, we need to make sure that we install the open SSH packages, and so we can have the certificates in place as part of that process. So you really have to think about all the different dependencies from the infrastructure level all the way up through to your application level, all the jars, ears, and wars that are needed to make that version of your application run. Now, the next step I recommend doing is installing an Nginx. And I normally say install this natively. And what this is going to allow us to do is going to give us a front end to give us an entry point into our container world. Even if we're just doing a Docker run or Docker exec of our application, we want to have the inbound transactions hitting Nginx first. And the reason is Nginx is a really easy place where we could put our certificates for our SSL. It gives you some basic load balancing, and also gives us a way to do a reverse proxy, which we'll end up using later for our microservices. Nginx really isn't that hard. It's basically one configuration file. And there's some pretty good docs out there around it. But what we're going to do is basically take our transaction coming in, go through Nginx, and push it onto the backside of our Java application that's running in the container. So after we have those pieces, so we have our Java application running in the Docker container, we have our Nginx outside of the container world. Next, we'll go ahead and move that Nginx setup into a container. It's really basic. There's some base images out there for Nginx. Basically, all you have to do is copy in your configuration file, and all the other dependencies have already been taken care of for you. So this step, it's like an hour at the top, especially when you have it already running from the native side. So this is going to allow us to now run Nginx container. and our Java application as a container, and we'll forward the traffic in from the Nginx onto the back end of the Tomcat or JBoss, for example. So from there, we have our 2 containers. We have basically our load balancer, which is our Nginx, and we have our Java application. Now we need to build our Kubernetes cluster. One of the things I recommend is just go with Google. The GKE, the Google Kubernetes environment. Google will give you, I think, $200 or $300 free credits when you sign up. And their dashboard is the easiest I found to use across the different cloud providers. There's going to be the cloud side, which you go into your console, configure, set up your project. That basically says, hey, Google, this is a Kubernetes project. They'll go ahead and provision the cluster, and then it'll tell you the commands to run on your desktop side that allow you to communicate with it.
Summary from Kubernetes. Kubernetes is
So what we'll have is when you do the GKE part, you'll install a command line client on your side, and that's kubectl. And kubectl is basically the command line interface that allows you to talk with the cluster. The other part that you want to install is Helm. And Helm is a great templating engine. It's based on Go. What it does is allows us to create templates and pass variables into creating our Kubernetes cluster with our containers. So you have a Helm chart for your Nginx, you have a Helm chart for your Java application. Those will be used to move your containers into the GKE environment. So now we have our application actually up and running in Kubernetes, and we can see our traffic coming in. One of the things that Nginx will provide is the load balancer component for Kubernetes. So that'll be our ingress into the cluster, and then from there it'll push off the transactions to the back end to the different Java containers that we have running there. Once we get to that point, we have our application running. We have all of it in the cluster. We're still at the point of running an monolithic application. So the next step that we want to start thinking about is how can we break this apart? Now there's a great, if you go check out Microservices.io, they have a lot of documentation about domain-driven design. Basically, domain-driven design is how can I take my application and organize it in such a way that I can do inheritance. So for example, a single sign-on. The single sign-on microservice or component would be reused across all my application teams in my organization. That's going to be higher up in our domain that allows us to be inherited by other teams. Let's say we have a zip code verification service. That could be higher up or like in the middle of the domain-driven domain hierarchy, where some teams that are dealing with customer data are going to want to use the zip code verification. Other teams that are dealing with account numbers and those pieces are going to ignore it. So the domain hierarchy really allows us to take a look at how our application is really structured. Now, one of the things that we want to make sure is it's going to follow closely to your Java class hierarchy, but it's going to be a little bit higher up. So like I said, think in more functional terms like single sign-on, zip code verification, address verification, user management. Those types of functions are going to be part of your domain-driven design. And with DeployHub, we built this into DeployHub as part of our process, helping you organize where those different components are going to go in the hierarchy, and really make the collaboration easy so people know what's out there and how they can use it. We don't want to have somebody redo single sign-on again. We want to make sure that they use the standard one, that we can fix it once and have everybody use it. So now we have our functional pieces in place. What we want to do is really start looking at our build process. As we break apart our application into smaller pieces, what we're going to end up with is we're going to pull that code out of our monolithic and move it into its own repo in our Git repo. And that's going to let us have its own life cycle. So it can have its own path for production, whether it's going to go quickly or if it's going to go slow. It doesn't really matter. But what we have is that location for that source code, because our source code is starting to get smaller. We're going to go from hundreds of thousands of lines of code in our monolithic to maybe 10,000 lines at the most. And that's going to be a large microservice that we're going to have in our breakout of our monolithic. So when we do this, we want to make sure that every time we have a microservice or a component that we build it, we do our check-in, we build it, and then we publish that result out to a binary repo. And this is going to come into play when we start doing like our Docker builds. We're going to pull the pieces of what we want into our Docker microservices. So when we do the build, it's two steps. We have the build of the component. So we're going to build a jar file, and it's going to perform a certain microservice event. You know, like I said, it's going to do single sign-on. It's going to be the event. That's going to be then stored into the binary repository like Artifactory, Nexus. From there, when we do the build of our Docker image, we're going to pull from there and place that jar file into our Docker container. Now, you may decide that you're going to move off of J2E and you're going to mix and match. You want some Python code, you want some Go, you want some Rust. It doesn't really matter at the microservice level, and that's the beauty of it. You can mix and match for that type of transaction what makes the most sense for the language to support it. But what we're going to do is we're going to pull from our binary repository, our artifact, place it into our container, and we're going to do that doing our CI/CD process. Every build we do, we're going to keep track of, because one thing with containers is they're immutable. You can't go back and fix the container. You throw it away and you create a new one. So now we have our application broken out, and we start adding new microservices to our Kubernetes cluster. We need to start keeping track of what's happening and what the relationships are. And one of the things is DeployHub was set up to do that as part of the CI/CD process. There's a hook that we do like in Jenkins or Circle CI that we snapshot, even like a cloud build up on Google. We'll snapshot and grab information about the Git commit, the Docker SHA that was created, you know, so we have a link from the source code repository to the Docker image, and then from there, DeployHub will track who's consuming those containers, those versions of the containers, and where they're being deployed to. Are they going out to production cluster? Are they just being tested in development? DeployHub has, through that domain-driven design and this versioning engine, is able to keep track of all that for you. So what do we end up with at the end of the day? So what we have is our front end, which is going to be Google Cloud in our example, and that's going to have, it has a load balancer built in at the cluster level. Typically, you don't have to worry about configuring that. You basically just have your ingress coming in. So a transaction is going to come in through, hit Google's public IP address for your cluster. It's going to go through that load balancer, and then it's going to work its way over to Nginx. From there, it will go ahead and Nginx will determine which container that we need to go to for that transaction. And that's where the reverse proxy is used to allow us to route based on this transaction, who's going to provide the result for that transaction. And then from there, those applications, those containers, those Java apps are going to be communicating with our database. In this case, we just have one database that we're working with for our application, and that's typically external to the cluster. You could use your own on-prem database if you have like Oracle or DB2 on-prem. You could be connecting up to that, or if you're going to use one of the cloud providers databases, you're going to have a single instance of that. Now the database itself may be replicated in high availability mode, but when you connect between your Java application and your database, you're basically creating a single connection. Now the secrets, we didn't really get into those today, but secrets allow us to do things like store SSL keys, database login, user ID, passwords, and those are part of the process. When you build your cluster, you can upload your secrets to GKE and store them up there safely. They're all stored encrypted, so only Kubernetes can decrypt them at runtime. So when we look at our applications, we really need to start looking at what is the pieces that go into it. You know, if you take an example of a user, we'll use this one. We have a hipster store here in this example, and the store has many different pieces to it. We have the security, we have the front end, we have a product catalog, we have payment services, and this is just a small breakdown. There's like recommendations, the shopping cart, you know, those types of things, logins, all those microservices are going to be pulled apart and put into their own repository and their own containers. So when we do this, we're going to have a lot more different repositories in Git. But what it does allow us to do is we have more to keep track of. But what we have is the ability to, let's say, take a user login, for example. We can go ahead and make that user login its own microservice, its own repository. We can set the security up so only certain people can update it, but people can consume it. And when we find a bug in that, we're only going to go to one place to change that. And when we check in the code for that, that's going to have its own workflow that's going to kick off through Jenkins or Circle CI. And that's going to create us a new container at the end result. Now, because the timing is going to happen, we may get the login routine stabilized, and we may not touch it for another 10 years. So even though we're going to have many Git repos that we're dealing with, 80% of them after you get your application out into live production are going to stabilize and become, you know, basically you can ignore them because they're not going to have that much change. You're going to have about 15 to 20% of your application that's going to have a high change rate. And that's where you want to be really focused on, is what's happening in those, and make sure that the other ones, they've been tested, they're rock solid, we could just ignore them. And this allows us to really look at how the application is being put together at the microservice level, which versions, which new features are related to the other. The domain-driven design really helps with this, to understand the relationships, especially when you go beyond just a single application and you're moving to hundreds of applications at a company. How are all those hundreds of applications consuming different microservices? Now, one of the things that we'll do is DeployHub. We'll go ahead and pull together across all the different repositories. So you can think of DeployHub or an application version as sitting above your repository. So it's like a super project that is going to really take a look at all the different versions of the microservices and how they relate together to create a version of your application, or in our case, which version of the hipster store we have. So when we do this, what we'll have is, you go to the microservice world. When we start building code, we're actually going to stop really compiling code. When we have a monolithic application, it was, we'd use Maven, we use Gradle, we'd use OpenMakeMeister to figure out all the dependencies that went into the into the build process. And the builds are being shifted to runtime. And what this allows us to do is create smaller pieces of code. So a Python Flask application to serve up like a select query from a database is less than 100 lines of code. And it doesn't get compiled. So when we go through our CI/CD process, we literally check in our Python code. From there, we don't have to do any compile. We go right to the Docker build, and we just pull together the packages that are needed to run the application, the Python Flask. Now on the Java side, if we're sticking with Java, we're gonna have a smaller set of Java classes that we're gonna be dealing with. We'll still have Java dependencies, but it's gonna be a much shorter build. We're not gonna have 2-3 hour builds. We're gonna have a couple second builds that are gonna occur for when we break our application, our Java application to Java microservices. And this is going to introduce two different pieces. One is the Docker build and the container registry. So what we want to make sure is that we keep track of all this in a way to version and do configuration management. Because what's happening is in our Java build, we were originally doing all the dependency management at the build time. We would get a compile error, link error at compile time and say, oh, you got a bad dependency here. You got the wrong version of log4j, for example. But now this is being shifted with microservices to runtime. So instead of linking and a dependency resolution being done at build time, we're going to be doing it at runtime. And in order to make sure that we don't have any errors, we need to really keep track of the versions that are running and the configuration management aspect of that, how one version of one microservices needs to relate to another version of a microservice as part of that process. So I don't know if any of you have actually taken a look at Netflix microservices. But this is just a small part of it. We zoomed in. It's actually bigger than this. It goes into the tens of thousands of microservices and relationships that they have. This is typically defined as the Deathstar view of it. You'll see it as a round ball of just like blue. And what it is it's trying to represent the relationships between the microservices, how they related together, and which versions are being used by which other versions of the microservices. So it's really important to understand when you have an application. In the past, with our monolithic, we could say, this is it. This EAR file is our monolithic application. We know that this is version 5 of it. Now, when we go to the microservices world, what is version 5? We have hundreds of microservices, different versions. With Kubernetes, you can run multiple versions of the same service at the same time. So, and you can use service mesh to route to them. So it gets much more complicated, and that's where we really need to keep track of, from the configuration standpoint, of how they're related to each other. So we'll go ahead and look at how we can break it out in domain-driven design. So in our monolithic side, we had our front end, our database, our infrastructure, and we're going to be changing it up to smaller pieces. So we may start with just splitting front end, back end. That's fine. You know, you could do front end, separate all the JavaScript from all the back end. And that would be like step 1 of your progression to microservices. And then from there, you may take the front end and split it into the front end. Now we've taken out ads and recommendations. Then the next step, we were going to split out all the payment pieces, you know, our shopping cart, checkout, shipping, taxes. That's a different part of a domain that we could be using. And then things like sign up and log in. Those could be another microservice group as part of our domain-driven design. The credit card processing, you know, that one could be rolled into with the shopping cart, but we could actually split that out to make more reuse as part of that. Then finally get down to the database and to our infrastructure layer. So you can see as we go from this monolithic and really looking at the functional pieces of our application, that we end up with a pretty good hierarchy of how they're related together. Now, one of the things that we get to do is we get to really leverage through the domain-driven design the reuse. So if we have to present a different website to one customer versus another customer, or just two different versions, we have the Labor Day sale and 4th of July sale coming up. So the 4th of July website we're going to have, it's going to be red, white, and blue with flags on it. And then Labor Day, we're going to change it to a different look and feel. Those are going to be two different versions that we're having, but they're going to reuse the lower part of the stack. They're going to reuse the chart, the sign up, the credit card, database, all the way down. And this really allows us to have multiple streams or multiple versions of an application at the same time. So to keep track of that stuff, like again, we're going to jump back to DeployHub. We do have a SaaS-based version that you can start with, and it will allow you to go from the free version, which you can go ahead and get up and going. It's based on the free version on SaaS is based on our the Ortelius open source project, and then there's a paid version if you need to get into more security, more complicated domain-driven design as part of that process. So DeployHub and Ortelius will allow you to catalog, publish, and use that domain-driven design that we've been talking about. It's going to allow you to keep track of which versions of your components, applications, and services and the configurations around that. And also it's going to allow you to do fast and independent deployments. The deployments can occur not only to something like a Minikube that's running on your desktop, or if you want to go to Kubernetes on-prem or to AWS or GKE or Azure, it doesn't matter. DeployHub will support that type of environment. But the big thing that DeployHub is going to bring to the table is the configuration management aspect of managing microservices. Because when you start looking at it, this is the shopping cart for the hipster store. It has about a dozen microservices in it for our 4th of July sale. And we can really start pulling together all the different versions that are going to make up a specific version of the application. We're doing what the hard part is. Deploying something, doing a set image through your kubectl to update a Docker image in a Kubernetes cluster is easy. But if you ever try to look at the YAML file for a Kubernetes cluster when there's 1,000 microservices, 1,000 containers running in it, it's just not manageable. YAML is a great language to provide some structure. It's better than XML. It's not as cluttered, but still there's so much data that's being managed by Kubernetes that becomes overwhelming, and that's why DeployHub will give you that unique look at how your application's put together. So with that, it looks like we have some questions coming in throughout the part, and you guys can throw one at me and we'll go from there.
Awesome, awesome. Well, yes, if you do have a question for Steve, please go ahead and use your GoToWebinar control panel and go ahead and get those in, and we will go ahead and start out with the questions. The first one here is there a way to capture the application dependencies when migrating an app to a container for the first time?
Yes, so if we're talking like a Java application, you can look at your build, and it's going to give you what's being done at compile time, what you're dependent upon. You can figure out that you're dependent upon a single sign-on library from Oracle, for example, or if you're dependent upon LDAP integration from over here, or if you have some sort of database driver that's needed. You're going to use an Oracle JDBC driver. Those are going to give you the high-level dependencies of what is needed to run your application. But the relationships between like a user and an account, those are going to be more developer-oriented. Developers are going to have to tell you and really lay out how is a user associated to account. Your database schema can be used at that level as well. One of the things that, if you think about going to pure microservices, every single table you have, you're going to have your CRUD, you create, retrieve, update, and delete. You're going to have 4 transactions for that table that you have to do. So for every table, you're going to have 1 microservice. You could think of it that way. You could break it down further and to have a microservice just for the retrieve, but I think that's a little too granular to start with.
Okay, all right, great. Next question. Let's see, with Nginx, is that a cluster or else on prod? How to manage single point of failure issue?
Okay,
Sure.
I think I got that one.
Okay.
So initially, if you're doing Nginx, and when we talk about that migration piece, our roadmap at the very beginning, that roadmap getting you up to where you're getting into the cluster, all that I would be doing in development. I would not be trying to run a Docker container in production without any Kubernetes around it. One of the things you can do is the benefit of Kubernetes is if you just take our Tomcat application, put it in a container, put it in into Kubernetes, we have a replica set of one pod basically, so there's one instance of it. And if the thing fails, Kubernetes is going to restart it for us. So same thing with Nginx. If we put Nginx in there as well, that with the way the Kubernetes works, if that fails, it's going to restart us automatically. I would not, I'd be hesitant to go ahead and just run Docker, do a Docker run in production of an application, just because you don't have the high availability and redundancy that Kubernetes brings to the table.
All right, great. Okay, next question. Can you expand on what you mean by DeployHub is a modern configure and deploy solution? Does this refer to the microservices configuration only?
Yeah, so DeployHub will work with your existing applications, so it can deploy monolithic applications. We have one of our largest customers deploys WebSphere files out to their production environment with DeployHub. And they're in the process of, the developers, because it's a financial institution, the developers are in the process of breaking things out into smaller pieces. So they're actually going through a hybrid world. So they're going to have new services that are going to be running in Kubernetes and containers. They're going to be talking and back and forth with their monolithic. So they're going through a process of breaking apart their monolithic into microservices. In new applications, they're just starting right down the microservices path. So DeployHub can work with your existing monolithic world, the hybrid, or a pure microservices world. And we didn't even get into how service mesh comes into play with the advanced routing that can do. And DeployHub works in that world as well. All
right, great. Still plenty of time, guys. If you have a question for Steve, just use your GoToWebinar control panel. Our next question is it recommended to run an RDBMS within a stateful container instance?
You can. You'll see out there that you'll find like a Postgres, and we do this for DeployHub's on-prem Docker container. We actually will mount a persistent volume for Postgres. So the data volume lives outside of the container, but what's running in the container is the Postgres process. This can be done with other databases as well, with MySQL, et cetera. So, that type of thing. One of the things that you'll run into is you can only run one instance. So you can only have one instance of the container going up against the persistent volume that's being mounted. You can't have two separate Postgres processes, for example, hitting the same file system structure. It just corrupts the database. So you can do it, but if you have the option to go ahead and go with if you have an Oracle cluster that the DBAs have set up and you just need to connect to that, go ahead and just do that type of connection. Instead of trying to do all the work, you're trying to get Oracle to run in a container. You're better off just going with the native Oracle cluster install, for example.
All right, great. Next question. How do we ensure different versions of a deployed application on a container? Is it through different versions of container images on Docker Hub?
Okay, so we'll back up a little bit on how what happens when you do a Docker build. So when you do a Docker build, it actually is going to do your run commands. It's going to run like your yum install, your apt install of your packages. And every time you do one of the Docker commands, it's creating a new layer. Basically, it's a new zip file, and they're called layers in your container. So every single time you do a new command, it creates a new layer. And all those layers are then kind of squished together and pushed up to your Docker repository registry, like Docker Hub or Quay. Google has one, AWS has one. And what ends up happening is at the completion of your build, you end up with a SHA number. This is the hex number for this image. And that's really the true version of your image. That one that's an immutable number. Now you can do tags. You can tag the number. You can tag this SHA as version 1.5. But one of the problems is that's mutable. Somebody can come along and decide that instead of it being this build, we're going to make 1.5 this other build. So you really have no way through the tags to get back to the true source of it. So with the Docker SHA, that's where you're really going to be keeping track of what's in that. What I like to do is during the build process, there's in the Docker label command in the Docker build file, you can label the container, and you can actually insert things like it's like a comment. You can insert the git commit number, where the git repo was, who did the last commit, where was it built, those type of things you can put in the label, and you can inspect the container down the road and pull out that label. So if you really need to get backwards to something, you can do that. The other thing you should look at is doing a combination of when you label your images, that you label them with a semantic, v1.5.5, and the git commit. So I like to smash together in my label both the semantic version and the git commit SHA. And that gives me a way to really look quickly and figure out what's going on with those containers.
Okay, great. Next question. Would you change something in your migration flow if you were migrating to AWS instead of Google Cloud?
No, the cloud providers are all basically the same around Kubernetes. So whether it's going to be Google, Azure, AWS, they're all going to provide a level, a dashboard they're going to provide a command line interface for you to communicate with the different whatever provider that you're doing. Most of the time is you do a config step. So like in Google, I think it's gcloud config, and that connects your local Kubernetes, your kubectl command up to your Google Cloud. So what ends up happening is there's an abstraction layer that's in the middle, and that's where that config happens. AWS is going to have it, Azure is going to have it. If you're using like Rancher for on-prem, that's going to have a layer that you just run the config step, and then from there on out, your kubectl and your Helm look like it's just local.
Excellent. Okay, so many great questions. There's still time, guys. If you have a question for Steve, just use your GoToWebinar control panel and submit your question. Next question, how does DeployHub compare to AWS CodeStar?
I'm not familiar with AWS CodeStar, so I really can't answer that one. I'd have to go, we can grab the person's email on that one. Yep. I'll have to do some research and get back to them.
All right, we can do that for you. Next question then, would Nginx interface with the Kubernetes API server or directly with the kubepods during the reverse proxy?
The way I've set it up in the past is the Nginx is the type load balancer in the Kubernetes cluster, and that allows you to do your ingress into that into the load balancer part of the cluster, and that's actually running Nginx, and then Nginx will forward on the transactions based on its reverse proxy mapping that you've set up. You don't have to use Nginx. I found that it was just easy for the reverse proxy piece to set up. But if you don't have to do the reverse proxy and do a bunch of fancy mapping, you can go and use the Kubernetes native load balancer.
Excellent. Okay, let's see. Next question. What about a service mesh?
Okay, so service mesh, most of them, the ones I've played with is a lot with Istio, and Istio is based on Envoy. Basically, what service mesh is a way to go ahead and look at when you get a HTTP request coming in, it'll break out all the headers for you. It'll break out, gives you a lot of detail about the transaction. Basically, anything that's coming across in the packet, you can query. Now, what this allows us to do is we can look at a header and say, this is the authenticated user ID. And based on that user ID, we can now do basically an if then else. If the user ID equals Steve, then route this request to version 2 of this service. If it's not Steve, then we're going to route it to version 1 of this service. So it really allows us to pick and choose how the routing is going to happen at a lower level. Also, you can throw in your own headers, so you can create like a feature header. So if you have if you want to have like a feature, like a beta feature, for example, you can go ahead and throw your own custom header on there, call it beta, and when it comes into the service mesh, you can query if that feature exists and is equal to beta, then I'm going to route this transaction to this version of the container. Otherwise, go ahead and route to the default one. So the service mesh really allows us to pick up and run multiple versions of the same container at the same time and route different transactions to where they need to go based on data coming in from the client side.
Okay, great. All right, so many good questions. The next one here, what is the difference between DeployHub functions and garden_io? I'm fairly new to microservices.
Okay, so one of the things that we do with the DeployHub is we recognize that when you do a deployment, you're going to have the need to do a pre-post, a pre-action or a post-action. And we do that at the component level, which is basically the lowest level. That's going to be your Docker image is going to be the component level. And then from there, you roll up to the application level, and you have pre and post at the application level. And then higher up than that is going to be the environment. What we are able to do with DeployHub's pre and post actions is we can actually, as a pre-action, go out and check to see if the Kubernetes clusters started or not. Let's say we're going out to QA and we need to have a new cluster provisioned for us to deploy our set of microservices to. The pre-action would go ahead and go out and start up the Kubernetes VMs and get the cluster running. And once that's going, it'll come back and let DeployHub know that, okay, everything's good to go. Now you can start with the deployment. Also, these come into play with more traditional applications. Tomcat was famous for not recognizing a new WAR file has been dropped in place. So everybody would have to do a pre-action to stop Tomcat, put the new WAR file or ear file in place, and then expand it and then start it up again. So that's where the DeployHub pre and post actions come into play. Now in the microservices world, that is going to evolve around the installation of your new service. And that's done through what we call a custom action, where we actually will run your Helm chart to do and apply the correct variables for where you are in your pipeline to that Helm chart, and that's going to go ahead and update your instance, your cluster from there.
All right, great. Next question, how do you debug mistakes in changing APIs? Unexpected partial breakage in the Deathstar network of dependencies, ...
That's where service mesh really comes into play, because what you want to be able to do, and this is a whole another presentation we can do all together, but I'll touch on it real quick. What you can do with service mesh, like I said, you can run multiple versions of the same service at the same time. Now, what this allows us to do is actually test transactions in production. So through our feature flags and the headers, I can tag my user ID as a QA tester, and when the transaction comes across to the service mesh, it's going to recognize I'm the QA tester, and I need to get routed to this version of the microservice. That's going to be using the same data, same production data as the older version. And if I break something, it's not going to hurt anything at that level. Now, there is some cases where you get into, where it gets a little more complicated if you have to do deletes, updates, those type of things, where we're going to be doing those on basically a mirrored version of the database, or we'll stub out based on where we are. If we're in production, we're not going to really allow that to happen. We'll go so far, and then we'll do a rollback. There's plans that you can put in place. Also, you're going to be having to deal with how to deprecate something as well, and keeping track of who's using what, and telling somebody, this project team, you're 3 versions behind. You need to get on the latest version because we want to get rid of your old stuff because it has bugs in it and we found security flaws. That type of relationships you have to know in order to keep track of who's using what and when and where.
All right, great. So we're about 6 minutes to the top of the hour. I think we have time for 1 or 2 more questions.
Sounds good.
Okay, great. So how do we implement a messaging broker like Kafka or RabbitMQ as part of a microservices-based application architecture?
So those are going to be those types of brokers are going to, you're going to containerize them, and you'll more than likely be just running one instance of those brokers instead of trying to do replica sets and scaling, because those brokers have built into them themselves the ability to scale. And the way, depending on which ones you're using, you get into the whole master-slave relationships, and if this one fails, it goes on to this other one. So what you'll end up doing is relying upon the standard architecture of the brokers, but containerize them and just run them as a replica set of one in your containers. In your clusters.
All right, great. So let's see, what do we have? Next question, we have a mixed environment. Can DeployHub do deployments for both microservices and monolithic environments?
Yep, we kind of touched on this earlier. We can focus on your pure monolithic, deploying out the WebSphere, JBoss servers, Tomcat, or we're going to go out to IIS servers with new assemblies and DLLs, that type of monolithic, or you're in the hybrid where you got some pieces broken off. Some are in Kubernetes, some are still running in WebSphere. We can handle that. One of the things that we're going to do in that hybrid world is we're going to bring it up to a logical view of your application. So we treat everything as a component, not only the monolithic, the microservices. If you have database components, you have test case components, load balancing components. If you have, performance monitoring components, all those are rolled into a version of an application. So we give you that high level 80,000 foot view of what your application looks like, no matter whether it's monolithic, hybrid, or pure microservices.
Excellent, excellent. Okay, so we're about 3 minutes to the top of the hour, so I'm going to go ahead and close out the question and answer period. Thank you to everybody who did submit questions, and if we didn't get to your question, I apologize. Please know that the folks at DeployHub will be getting a copy of all of the questions, and so they'll be able to follow up with you offline, including the AWS CodeStar question. So yeah, so that'll be happening. So I also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, that's cool. You will have the opportunity to do so. We are going to be sending out an email later on this afternoon that contains a link to access the webinar on demand. And the webinar is also going to be on the devops.com website, so you can always find it there. Just go to devops.com/webinars and look in the on demand section, and it should be right there waiting for you. And while you're there, please take a look at all the other fabulous webinars that we have both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Steve Taylor, thank you so much for such a great presentation. Judging from the number of questions that we got, I know the audience got a ton out of it. So thanks very much.
No problem. Thanks for having us.
All right, great. And I want to thank the audience also for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.